All right, let's talk a little bit about what mutually exclusive means. Two events are disjoint or mutually exclusive if one event cannot possibly occur at the same time as the other event. This is totally different than independent events. We're talking about only performing an event or experiencing an event one time, and we have different things that could happen on that event. And so that's different than independent events, which is like doing two different trials. Okay, so here we've got flipping heads or flipping tails on a coin. Those two events could never happen at the same exact time, so they're called mutually exclusive or disjoint. Picking a red sock from a drawer or picking a green sock from a drawer. If we want one that's totally red or totally green, then those are totally different types of events, and so they're mutually exclusive. They can't happen at the same time. If you want to find the probability of mutually exclusive events occurring together, then you would simply add the two probabilities together. Now this U between A and B represents the union of A and B. We're combining them. And when I use this, when I speak this idea, I use the word or to represent it. And so this is the probability of A or B occurring. We can just add the probabilities of A and B together. Okay, so here's an example of two mutually exclusive events. Suppose that we roll a dice. What's the probability of, and here are the two events, rolling a 3, that's our first event, or we could say, well, we actually could also hope to get a number greater than or equal to 5. So what's the probability of either of those events happening? And we're only going to roll the dice once, by the way. So what's the probability of rolling a 3 or a number greater than or equal to 5? Well, the probability of rolling a 3 is simple. We only have one 3 and we have 6 numbers on a die. So 1 out of 6. Now, what's the probability of rolling a number greater than or equal to 5? Well, we could either roll a 5 or a 6. So that's 2 options out of 6 numbers on a dice. And so what's the probability of at least one of those happening? So either rolling a 3 or rolling a number greater than or equal to 5. We can just add our two probabilities together, and we end up with 1 over 6 plus 2 over 6. And that's going to equal 3 over 6. And of course, we always simplify whenever possible at the end. So 1/2. And this hopefully makes a lot of sense to you, because we're saying we're going to roll a dice, and what's the probability of either getting a 3 or a number greater than or equal to 5, which would be 5 or 6. So that's 3 different ways I could get this to happen out of 6 possibilities on the die. So that's my 3 over 6, or 1 over 2. Okay, so I have one more practice problem. This one's pretty similar. Suppose that you draw a card from a deck. What's the probability of picking a 4 or a 5? So we can either get a 4 or a 5. So I'd like you to pause the recording and write down the answer to this and work it out. And once you're ready, unpause and we'll check our answer. All right, I'm going to do a bit of a reveal here. So let A be the event of picking a 4. Hopefully you found that the probability of picking a 4 is 4 out of 52 total cards. And it's the same for picking a 5. There's 4 5s in the deck, so 4 out of 52. So if I want to either pick a 4 or a 5, then I would add those two probabilities together, and I would get 8 out of 52. And if I simplify that, divide them both maybe by 4, then I would get 2 out of 13. And you could also, just look at this and do it all in one go. You could say, well, how many 4s and 5s are there in the deck? I could either get a 4 or a 5, and there's 8 of them in the deck. And there's 52 cards total, so 8 out of 52 or 2 out of 13. All right, so that's it for mutually exclusive events. So please make sure to watch the last video. Well, the last video about these events, and then there will be one more with some practice problems.